Hello everyone. In this video, I will briefly introduce the key challenge that the RELIFLOSS project aims to address. The RELIFLOSS project focuses on enhancing the reliability and reducing the costs of floating offshore wind turbine support structures. This project is funded by the Engineering and Physical Sciences Research Council, EPSRC, through the Innovation Launchpad Network Plus Researchers in Residence scheme. The project is a collaboration between the University of Nottingham and the Offshore Renewable Energy Catapult. When compared with onshore locations, the wind offshore is generally stronger and more consistent. In addition, there is much more available space to deploy large wind turbines offshore. These advantages have driven the wind energy industry to increasingly move from onshore wind farms to offshore wind farms in recent years. Offshore wind turbines can generally be divided into two main types: bottom-fixed turbines and floating turbines. However, most offshore wind resources are located in deep water areas. Because bottom-fixed turbines can only be installed in shallow and intermediate waters, they cannot access these deeper wind resources. As a result, floating wind turbines are becoming increasingly important as they allow us to harness wind energy in deep offshore regions. Floating wind turbine support structures operate in harsh marine environments with significant uncertainties. For instance, wind and wave loads can vary greatly, creating complex conditions for these structures. As a result, designing floating wind turbine support structures that are both reliable and cost-effective becomes a significant engineering challenge. Currently, the design of floating wind turbine support structures is mainly based on the partial safety factor method. In this approach, engineers apply partial safety factors to account for uncertainties in loads and environmental conditions. However, this traditional design approach can sometimes result in structures that are either over-engineered, leading to higher costs, or under-engineered, which may reduce structural reliability. This project aims to develop a reliability-based design and optimization framework for floating wind turbine support structures, improving both their reliability and economic performance. The framework combines machine learning, stochastic structural modeling, reliability assessment techniques, and optimization methods. By integrating these advanced methodologies, we aim to design floating wind turbine support structures that are safer, more efficient, and more cost-effective, supporting the global transition toward clean energy and net zero emissions. Thank you for watching. If you are interested in offshore wind energy and floating wind technologies, please stay tuned for more updates from the RELIFLOSS project.